everyone. So today we are starting the lecture series of the software project management. The today's topic is your sequencing and scheduling of the activities. As the name declares, the sequencing and scheduling. So you should have a basic understanding of what do you understand by a sequence or what do you understand by a schedule. If we talk about a sequence is just like your timetable. You are having a timetable to have your lecture series. You have having a timetable to know what lectures today you will have. You're having a sequence for that. For example, you're having the first lecture of a data structure, then you're having a second lecture of a discrete, then you're having your DAR lecture, or you're having an SPM lecture. So that is a sequence of an hierarchy that you are following a timetable, or you are having a flow of the lectures on a single day. So that can be done through a schedule. So we have to maintain a schedule that how we have to perform the lectures, or we have to deliver the lectures by which the students get complete information about the subject. So if we talk about a simple definition of the sequencing, it says that throughout a project, we will require a schedule that clearly indicates when each of the project activities is planned to occur and what resources it will need. Definitely, the project, of course, it needs the sequencing and the scheduling. That, of course, the project is having the different modules, isn't it? So for completion of all these modules, what we have to do is that we have to perform the proper sequence. We have to declare a sequencing of all those steps. And with that sequencing also, we have to schedule that. For example, we have to complete the module 1 in 1 week. And then after completing one module, we will move on to the second module, by which the performance can be done in a flow way. We can have the formation of a completion on a single way out, isn't it? So for that, sequencing is to be done. And of course, the scheduling is to be done for the proper completion of your project. For example, you know very well, you have seen a number of the places that the flyover construction has been happening, isn't it? And the date has been mentioned there itself, that the duration has been mentioned that this flyover will get completed by a 1 year or by a 5 years. So how the person or how the people will be came to know about that the project of the flyover construction will get completed? It is only on the behalf of the sequencing and your scheduling. They have done the sequencing of all the modules, that how the performance of the project will happen. They have done the scheduling of each and everything, not about the softwares, not about the people they are working, not about the resources. Each and every point, it should be added on to have the scheduling part. Okay, so I hope you understand the basic definition for the sequencing and the scheduling. So it's mentioned here, one way of presenting such a plan is to use a bar chart as shown in the next slide. So you know very well that it's a human mind tendency that the people easily understand, they visualize, they can understanding more with the help of an images instead of a text message. For example, we are having an example of one project. Here the people at the one place, it's mentioned the task, the person, that means the Andy, the Bill, the Charlie and the Dave. And at the top of the columns, it mentioned the weeks, that is the 1, 2, 3, 4, 5, 6, 7, 8 till 13th week here it's mentioned as an example. And of course, on the left hand side, they are also mentioned the modules name, that is the A is your overall design, B is the specify module 1, C is the specify module 2, D is the specify module 3, E is the code module 1, and similarly, rest of all are declared here itself, isn't it? So what happens is that you can see this bar chart. For example, the first bar chart is representing that the Andy, the person Andy, have to complete the overall designing part by the 1 week. It's mentioned week 1 is having a black bar, which is representing that the Andy will be able to complete the overall design by the 1 week. Similarly, the second work assigned to the Andy is to have the specification of the module 1, which should be completed by the second week. So the bar chart mentioned here, the black box mentioned here is the second week, isn't it? Here it is mentioned the second week. Similarly, the Andy is having a third assignment, that is the specify module 2, which has been done by the third week. Similarly, at the fourth, the Andy is given the work of the specify module 3, which is to be completed by the fourth week. So all the 4 weeks Andy will have to complete, and in parallel, it is having the responsibility by the Bill, which will start from the third week. What he has to do? He has to do the code module 1, because the module 1, the part is already specified. So he will going to start this process parallelly when the module 3 work is been started up. So Bill will start the work with the Andy in parallel in the third week of the project completion. Okay. Similarly, this bar chart, for example, the Bill is working on the code module 1, and what he will do, he will complete this work from the third week till the 5th week, isn't it? Similarly, the Bill is having the F module, the code module 3. He will start this work from the 6th week. Okay, from the 6th week, it will move on to the 8th week. Getting my point, everyone? So, similarly, the Charlie is the G, he was assigned the code module 2. The code module 2, he will start from the 4th week and he will finish this work by the 7th week. Fine. Similarly, the H module, that is the integration testing. The testing will be done when all the modules will get completed. Till the 8th week of the project, all the work has been completed. Getting my point? Now the testing part has been started, which is your 9th week. Here the completion part is there. Fine. And similarly, then the 10th point, that is the 10th week, what we'll do? The DAVE, the I, that is the system testing will be done by the 10th week to the 12th of the week. So by the 12 weeks, we will complete this project. Now think about that. If instead of this visualization of the bar chart, if possible, we are representing this work in a text format, what will happen? If I'll mention simply that the A, that means the overall designing by the Andy will get completed by the 1 week. Similarly, I'll mention, for example, the E part, that is the code module 1, will be completed by the Bill by the 5th week of the project. So if I mention in a text format, in a theoretical format, I'm not able to understand more clearly about that thing. We have to read out all the statements, then I have to conclude. But with the help of this bar chart, we can easily understand what work is parallelly been happening, what work is happening, scheduling, what is done, when the project will get completed, what module will complete at what duration. So we're having a clear picture that how and what is happening where. You're getting my point? So I hope you understand how the activities of the project. What are the activities? That is the small parts of the project. The activities, the work assignment given to the project has been declared, it's been defined by the weeks itself. And with this clear picture, I can declare, I had already defined one example of a flyover, isn't it? The flyover says that after the 5 years, my flyover get completed. Similarly, with this picture, I can clearly define that this project will get completed by the 12 weeks. Getting my point, everyone? Okay. So what it says that in drawing up the chart, we have to done the 2 things. हमें 2 काम करने हैं. First is the sequencing of the tasks. That is, they identified the dependencies among the activities dictated by the development process. See, in this picture, what happened is that we cannot complete or we cannot start, the Bill cannot start what the Bill is doing. Bill is doing the code module 1. He cannot complete or he cannot start the process of the code module 1 till the Andy will do the specifying module 1. We cannot complete because first of all, the module specification has been required. That means it is having dependent on the B. That means the Bill is dependent on the Andy, isn't it? So we have to initial level have to identify the dependencies of my activities. That which activity should be started when it is required, isn't it? They are not parallel. We cannot execute all the activities parallelly, isn't it? We have to identify the dependencies, we have to calculate what the dependencies are, then we have to plan out that which activity should be performed when. Clear, everyone? So similar statement is defined here itself. Then it's mentioned scheduled them. We have to schedule, that is the specified when they should take place. कब उसको हमें perform करना है, isn't it? The duration of the weeks has been mentioned. Then when we have to perform the task, which task should be performed before, then which task should be performed later. That we have to declare by the bar chart itself. Fine. So then it's mentioned here, the scheduling has had to take account of the availability of the staff and the way in which the activity have been allocated to them, isn't it? Of course, it depends on the people who are working on the project. We have to take the permission from those people. We have to take the responses from the people who are working with the code. We have to declare the activities with them. We have to ask them that for that module, how much duration will be taken by you, isn't it? The clear picture should be there. And after that, this bar chart should be designed by which we can have the clear scenario that how much duration your project will get completed. Okay. Fine. So next is your network planning model. So what is network planning model? As you know, what is network? Network is a connection of the nodes and the links, isn't it? The network is always having a start node and the end node. If you are starting our project, definitely it is having an ending point. What is the ending point? That is the project completion. But how we can show that network plan? So it says that the project scheduling techniques models the project activities and their relationship as a network. And the network time flows from left to right. As I declared about the network, that it comprises of the nodes and the links. Definitely, the connectivity links are having the flow. Of course, the flow will be from the starting to the end. We are starting the project, we are moving to the end, and the flow will move from the left to right, of course. So talking about the two technologies for the same or two models we got the same, that is the critical path CPM, critical path method, and the second one is the PERT one, that is the program evaluation review technique. Both of these techniques use an activity on arrow approach. We have to show the arrow representation to visualizing the project as a network where activities are drawn as an arrow joining circles or the nodes. We are having the nodes, we are having the lines between them, and we have to show the flow between the starting node to the ending node between all the nodes present during the project completion. Okay, so it's mentioned represent the possible start or the completion of an activity or the set of the activity. Okay, so further it is saying that now the precedence network has become popular, which uses the activity on node network where activity are represented as nodes and links between the nodes, representation, sequencing, that is the requirements. So for constructing the precedence network, we have to know certain points for that. For example, we should have, the first point it says that we should have a starting node. Of course, किसी project को start करने के लिए एक initial node की requirement पड़ती है. I told you before, definitely we need an ending node also for the project completion of that. Definitely. Then we have to declare the node duration. For example, if I want to traverse from the first node to the second node, then how much duration it will take? We have seen in the previous slides about the bar chart, that is the duration. The first week, the second week, the third week, how much weeks it will take to complete that module. So for that duration, I have to mention between the links. That means in the precedence network also we have to show the same representation. Getting my point, everyone? So further it is saying that links normally have no duration. Precedents are the immediate preceding activities. And the time moves from the left to right. Our network may not contain the loops. Of course, loops is, we will have a circular loop. It should not format like that because parallel execution has been there, but the loop formation will create a problem in the projects. Our network should not contain the dangles. What are dangles? We'll further discuss about in detail more about that thing. So this is a small example regarding the precedence network. Precedence networks, as I declared that it is having the nodes and the links. If I talk about the code, data take on, the program test, the install, they all are the nodes. And it is having certain links for the connectivity. It isn't having a node code, it is having a node data take on. What will happen with the combination of this? We can have the program testing and then the installation and further processing can be done. It's just a simple example of a precedence network. Then further it is saying that a loop representation, impossible sequence. Why impossible? Impossible, why so? At the initial level, it's mentioned that is a code program. Fine. Then we have to do the testing of the program. And after my testing, all the errors are resolved. Then I have to release my program. But between it's mentioned here, we have to diagnose the errors. Of course, when we do the testing, it may be any testing, the system testing or the integration testing. It may be at the deployment side. It may be at the user side. It may be everywhere, isn't it? So we have to diagnose this error. We have to correct those errors. And then we have to test the program. And this program is move on again and again and again. Maybe possible, I had constructed my project, I had given to my customer and he start working on that project. But with certain issues, with having some problems, he is having certain errors. So I cannot say that definitely errors may occur at my side also, at their side also. So that is why it is saying the impossible sequence. Error can be get at anywhere. Getting my point? So that is why whenever we do the test for a program or whenever we start working on that program, errors may occur. We have to diagnose this error, we have to correct those errors, and again we have to do the testing and we have to release the program. The process will getting more and more further implementation regarding the testing and the error identification and then the releasing of the program. Clear, everyone? Fine. Okay, now coming on to the dangle. I discussed about the dangle, a single point about that. Dangle, what says is that we talk about this diagrammatic representation. Again, the designing of the program is there. Then the coding of the program has been done. Then the testing of the program is done. Then the installation of the program has been done. One link is representing to write the user manual. This is my dangle. Of course, when you're coding the program, may be possible. User manual can be designed at the previous point also, or at the initial level. Plus, we are doing the coding, updations has been done. We are working on that project. Maybe some modifications has been done. All that part we have to do the parallelly work, that means the user manual. But it is the connectivity only between the code program. So that is creating a dangle, which is not spreading the complete information to the whole process. So that should not be, should be like that. What it should be? It should be having the connectivity with the complete project. The designing of the program has been done, the code program has been done, the testing of it is done, installation has been done, and then the sign off. At the end, whatever the modification has been happening when we are implementing the program, At the end, we have to provide the complete process user manual to the end of the project. Getting my point? So that was a dangle. If it has been done here itself, I'm keeping residing with it. For example, I'm working on any of my project and I'm doing modification by my own and keeping it with me. But some of my team members are working with that project. I'm not informing all these points to them. What will happen is that they will get more and more errors. They will not get understanding of the rest of the modules, isn't it? So for that understanding, I have to define them maybe through the user manual, maybe through any other communication network by which he or she can have the complete information whenever they will do the project for the further modification of the project or whatever. But the complete information should be thoroughly declared to all the team members, all the people or the future people who will work for this project should have the complete thorough information. So that dangle should not be present in your project. It should be having the resolving process by having it at the end of the user manual. Getting my point? Fine. So representing the lagging activities, the lagged activity says that we might come across situations where we wish to undertake two activities in parallel so long as there is lag between the two. When the activities are having parallel, in the bar chart also we have seen that some activities are executing in parallel, isn't it? That at the end of the third week, one project has been completed, but before the completion of the third week, we are started the project at the initial level of the third week at some module. So we might wish to document amendments to a program as it was being tested, particularly if evaluating a prototype. In such a case, we could designate an activity test and document amendments. So if we find out that there are some changes in the module or any updations has been done through that, so we can have those amendment representation there itself. Fine. Where activities can occur in parallel with the time lag between them, we are representing the lag with the duration of linking an arrow as shown in this below figure. Build a prototype, test a prototype, and then review the specification. Whatever the amendments you are doing in the parallel of this module, that should be done here itself and it should be coded at the end of the project. Fine. Adding the dimensions may be possible. When I'm working on any of the project, I came to know that this should be having the more add-on. For example, I told you about that thing that for the construction of the flyover, I came to know certain resources are having the lag of those resources, or certain people I am in need of that people. I'm not having the expertise for constructing that flyover. So I have to identify more people. I have to add on more dimensions. Maybe possible this work assigned by one people, it may be divided to the two peoples. Isn't it? A task can be divided by the two peoples, isn't it? So that dimensions can be changed. Maybe the scenario can be changed. So it may be, we can say it's a runtime allocation also. I have to complete my module. I have to complete my project timely. So for the timely completion may be possible. At that time, some issues has been created. For resolving those issues, I may add more dimensions by which my project gets completed on their time. Fine. So it says that the method requires that for each activity, we have an estimate of its duration. I told you, for example, I have given the example of a flyover. In the 5 years, I have to complete that flyover. But due to certain reasons, the lag of the resources, the lag of the environmental hazards, whatever the problem issues we are facing, may be possible instead of the 5 years, we are taking the 7 years or 8 years to complete that flyover, isn't it? So for the estimation of the duration can be done by the two methods, that is the forward pass and the backward pass. So it says that for the forward pass, calculate the earliest start date of the activities, and then you have to calculate the project completion date. Getting my point? And in the backward pass, we have to calculate the latest start date for the activities, and then we have to identify the critical part from the graph. What is the critical path? We will discuss later more about details. But if I talk about in a single line statement, critical path is a part which is having the maximum duration to complete that project. Getting my point? That means from the first week till my project is completed, it may be 10 weeks, it may be 12 weeks, it may be 1 year, it may be 24 weeks. So that the maximum duration for covering that project completely is your critical path. Fine. More detail we'll have more examples about in the further slides also in further lecture series. Okay, so adding two dimensions continued. The example says that the project specification with estimated activity duration and precedence requirements. We are having certain more dimensions. For example, the dimensions mentioned here are the hardware selection, system configuration, the installation of the hardware, data migration, draft office procedures, recruiting the staff, user training, install and testing the systems. That is the duration we have mentioned, and then we are having the precedence mentioning. That means, for example, for having the installation of the hardware, what we have to do, I have to complete the hardware selection also. If I will not decide the hardware selection previously, I cannot install the hardware. So the precedence for the C part is that it is your A part. The A part should be firstly completed. Getting my point? Similarly, for example, I can take the data migration. It says that it should be dependent on the B part, that is the system configuration. So we have to mention the precedence, which value is having the precedence. First, which work should be completed, then I can start my process. Fine. Okay, so precedence network, for example, this is a simple project representation of that. The dimensions I had declared in the previous slide, these are all the dimensions which I had mentioned. Now, these dimensions and the duration and this precedence value will be showing in the graph. So, how it will show? You can see that the start is there, and then we are having the weeks defining, that is the duration of each and every dimension has been mentioned, isn't it? And these dimensions will get connected to the finish line. If I talk about that previous slide, for example, the duration of the hardware selection is 6, system configuration is 4, installation hardware is 3, similarly 4, 3, 10. So these durations are mentioned here itself, the 3 weeks, the 6 weeks, the 4 weeks, 4 weeks, similarly the weeks has been mentioned, isn't it? And the connectivity between the nodes by done with the help of the precedence network. For example, for completion of the installation hardware, it should be connected to the A part, that is the A. So we can check it here that for the installation of the hardware, it's mentioned for the installation of the hardware, it should have the connectivity with A. Firstly, the A should be complete, then the installation of hardware should be done. If I see the previous slide, only the 6 and 4 and your 10, that is the F, B and A, they are not having any precedence value. So that is the initial nodes for that. So 6, 4 and 10, they are not having any precedence network. So we are having simple part of that. Okay. So similarly, we can have the formation of this network. Forward pass, if I talk about, or the forward pass in more detail, we'll have an example in the next lecture series. Simply understanding for this is that we will add on the duration. At the initial level, we are having the 0. There is no duration. That means there is at the initial level, we are starting our project. Then for that, it says that we are having the 6 weeks for the completion of that project. That means 0 plus 6 is your 6. Similarly, the 6 will get move on to the next part. 6, then 3 weeks to complete the installation of the hardware. 6 plus 3 is your 9. Fine. Similarly, we have to do for that. 0 plus 4 is your 4. This 4 will move on here itself. 4 plus 4 is your 8. And similarly, 0 plus 10 is your 10. Then this 10 is moving on to the G part, that is here itself 10. And then 10 plus 3 is your 13. I hope you're getting a basic information about how the forward pass. We are simply adding on the weeks. Fine. Then the backward pass, we can having the backward pass. The backward pass is the subtraction of the duration. For example, initial level, we're having the 13. Then 13 minus 3 is your 10. Similarly, this 10 will move on to the here itself. Then the 10 and having the 0 at the initial level. Similarly, here I can say that 11 minus 2 is your 9. And this 9 will move on to here itself. 9 minus 3 is 6. The 6 will move on here itself. Then 6 minus 6 is your 0. That is your backward pass to identify that how the flow was happened. In detail, we will come on to the next lecture series. We'll discuss more examples for that. So, identifying the critical path, we have already discussed about that the maximum value taken by the time duration is your critical path. Identification can be done by the same example that how much maximum time we are taking for that completion. Further, we'll discuss in the next lecture series. Thank you so much.